Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 1st, 2025, just 2 days ago. It introduces a unified way of encoding images and videos into a single continuous representation, and with that one representation, it reaches about 61% on the MM-STAR understanding benchmark and 0.90 on the general eval image generation benchmark, matching or beating many larger multimodal systems. The paper is titled TUNA, Taming Unified Visual Representations for Native Unified Multimodal Models, and the implications for future multimodal model design are quite significant. Alright, the introduction set up the motivation for a single shared visual space, and Figure 1 now shows what that achieves in practice. The top collage illustrates high-quality image generation, with varied scenes that demonstrate both realism and stylistic control. The middle strip highlights two capabilities: image editing on the left and multimodal understanding on the right, where the model answers questions about a travel itinerary. The bottom row presents video generation, with sequences of coherent frames that follow prompts and preserve subjects over time. While Figure 2 shifts from examples to the actual pipeline that makes everything work, the left block shows images or videos, first passing through a VAE encoder and then a representation encoder, which together turn pixels into unified visual tokens. The central block illustrates autoregressive understanding, where those visual tokens mix with text tokens, flow through the large language model decoder, and produce text outputs. The right block mirrors this, but with a flow-matching head and VAE decoder that turn noisy visual tokens back into generated images or videos. Alright, the previous figure focused on how the pipeline operates, and Table 1 now shows what that design delivers on image understanding benchmarks. The table lists many competing systems by size and scores, with separate blocks for understanding-only models, composite unified multimodal models, and native unified multimodal models. In the 1.5 billion scale block, TUNA reaches the best overall average across benchmarks. In the 7 billion scale block, TUNA again matches or beats larger rivals, which shows that the unified visual representation scales very effectively for perception-heavy tasks. So the previous table focused on perception benchmarks, and Table 2 now reports structured scores on the general eval image generation test. The upper block covering generation-only models shows very strong overall performance, but it relies on larger, specialized systems. The middle composite block lags slightly, which reflects the cost of stitching separate components together. In the 1.5 billion and 7 billion native unified multimodal blocks, TUNA either matches or exceeds all peers, especially on single object, two object, and counting consistency, so the unified visual space clearly boosts controllable image generation quality. Okay, the previous table focused on pure image generation, and Table 4 now evaluates how well the models can edit existing images. The upper block of generation-only models sets a strong reference, especially for global quality on gedit bench. The lower block of native or composite unified models shows that TUNA achieves the best overall editing score, with balanced strength across add, adjust, replace, and style edits. TUNA also leads unified models on both semantic consistency and perceptual quality, so the shared visual space supports precise, faithful edits. So after image editing performance, Table 6 turns to text-to-video generation quality on vBench. The whole table compares one generation-only model against several native or composite unified multimodal models across quality, semantics, motion, and consistency metrics. The generation-only Cog Video X still scores strongly overall. However, the TUNA row at the bottom shows the highest total among unified models, with especially strong temporal flickering, motion smoothness, and overall consistency scores, so the unified representation scales well to video. So vBench showed how well the system handles video, and Table 7 now dissects why the unified representation matters. The table compares Show-O2, decoupled designs, and several TUNA variants under 3 training regimes: understanding only, generation only, and joint. Unified TUNA with WAN 2.2 VAE and SIGLIP2 Model 12 achieves strong image understanding scores while also topping general eval and DPG. Decoupled and Show-O2 models lose either understanding or generation quality, which indicates that a single continuous visual space lets both skills reinforce each other instead of competing. TUNA shows that a single continuous visual space can power both strong understanding and high-quality image and video generation without the usual trade-off between the two. The work also suggests that better visual encoders and joint training are key levers for future multimodal systems. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.